All right, so this video will take us through the next couple rules in our derivative chart. And this is where we left off with the last video, which was us adding the coefficient rule and the addition and subtraction rule to our growing list of derivative rules. And again, just a recap of this chart. The guys on the left there are sort of these, again, building block or just basic derivative shortcuts or formulas. I would call those more so formulas. That if you want to know the derivative of a basic character, there they are. They're all right there. And what did we add last time was, okay, these two extra things, which is to say, how do you deal with a coefficient, a number in front of a function? Or how would you deal with when you want to add or subtract two functions? Again, the idea being that the functions themselves are probably one of these guys or something close to these guys. So how do I deal with combining them in this way? What can I do? What can't I do? And these two rules so far help us deal with those two cases of a coefficient and also an addition or subtraction. Again, they could be used in conjunction with each other. So what else is there? Well, just sort of as a basic review of what second grade math, what usually comes after addition and subtraction might be things like multiplication and division. And indeed, those guys will have rules of their own. And those rules actually are not packaged together as a combined rule. They actually will have separate rules. So what this video will tell us is how to deal with the multiplication or the product of two functions, and also the quotient or the fraction or division of two functions as well. Okay, so and those will become rules 3 and 4. So much like I did in the last video, we'll add those guys in at the end so that they become part of our master list here. And eventually we're going for 5 rules. We'll have 5 rules by the end. And that's the whole chart. And that literally is the entire derivative chart, even for someone who knows a lot more math than you guys do. That's it. This is it. I don't have any tricks that won't be in this chart either. So it's actually very kind of nice to be able to so quickly get to all of what is known, about doing derivatives. All right. So on to our first of 2 rules then for today, which I guess is rule number 3 in our chart, which is what's called the product rule. Okay, where of course product refers to multiplication. So this is going to help us figure out how to do the product of two functions, maybe x squared times e to the x or something like that. Oh, e to the x is actually not a great example. Let me pick somebody else here. Maybe sine of x. Okay, so a question, right? So the question is, as it's been for a while now, is what's the derivative of this? So what's the derivative of x squared times sine of x? Now I know mathematicians don't do us a whole lot of favors in terms of notation, I guess, but hopefully everybody's aware, right, that kind of when you just put things next to each other with no symbol, addition or subtraction or division, by default it means multiply. So this does, just to sort of make sure everybody's aware, mean x squared times sine of x, right? And also, just so that everybody also is, since it's going to become more and more important to make sure we have the right understanding, right? Sine of x, which is what this is. That's not sine times x, right? Everybody's okay with that, right? Sine by itself doesn't mean anything. So it's always sine of whatever comes after it. So sine of x, that's what that is, right? So there's no multiplication there. But again, let me erase all the stuff I just wrote in there, right? That is interpreted as, x squared, that's one character or one function, times sine of x, which is a second function. Okay. So anyway, here we are. So we've got this issue where we want to know what's the derivative of this thing. And all right, well, so far we've actually done reasonably well with being able to say in our first 2 rules that if you kind of made a logical guess, that's actually, those guesses are correct. In other words, that's actually what you can do. You can just say if you have x squared plus sine of x, Then you just do the derivative of x squared, which is 2x, and the derivative of sine, which is cosine, and you add them together, and that's it. So it stands to reason, right, just by our guessing that maybe, if I want to do the derivative of this whole thing, that I maybe just do the derivative of each piece separately and multiply, right? So if I did the derivative of x squared, you'd get 2x. And if I do the derivative of sine, you'd get cosine, or cosine of x, I should say. And, you know, this would be great if it was right, but it's not. And this is where really the bad stuff, I guess, starts to happen. Sorry, I don't mean to be negative or pessimistic going into the next hour or so of your lives, but unfortunately, this starts to fall apart when we do multiplication. It gets even worse when we do division, and the worst case of all is our fifth rule. So, so this isn't true. So I should immediately, cross this out. If you already wrote that down in your notes, I'll do the equivalent of crossing out, which is to delete or erase. That's not true. So it's not true that you can just take the derivative of each piece or of each function and multiply. So, all right. Well, what is it that then I would have to, what should I do? Well, I'll spare you this, and I really do mean spare us, because I don't want to do it either. If I use the fancy definition again one last time, I'm not even going to write it down this time, but if I did my f of x plus h character and wrote that down, what would I be trying to do? Well, basically what you'd have to do is you'd have to sort of rearrange some pieces and do some sort of mathemagic in order to kind of rearrange some stuff and make it into a recognizable format. So for our last three rules, this one and then our next two, I'm going to be honest, I'm not even going to attempt to sort of prove them or derive them for you, because they're just kind of nasty. Instead, I'm just going to tell you what they are. So we should, of course, feel free to, use them, obviously, right? Just because we didn't prove them doesn't mean we can't use them. But let me do write down what the rule is first, and then we'll apply it to this, and I'll do maybe another example as well. So what should the product, so the product rule as it's going to be called. In other words, what do I do when I want to multiply, or when I am multiplying two functions together? How do I compute that? So, well, let me write down the rule under here, and then I'll use it in the example up there. So what does the rule say? The rule says if you have one function, I'll call that f of x times another function, which I'll call g of x. So just any two functions you want. And you want to know what's the derivative. Okay, so exactly our setup up top there. How will I do this? Well, let me write down what the answer is first, and then I'll sort of give you a little description of how to go about doing it. So the answer is you'll get the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, so this is a little bit of a mouthful, right? So you can immediately see this is worse than anything we've written down so far, but let's not freak out, right? What is it that I'm looking at right now? Well, I start with two functions, f and g, and I'm just going to say, when you're approaching a real problem, I'm going to do the one up there in just a second. But when you're doing this, you might even want to sort of just say to yourself, okay, f of x is, and then fill in what that is. And then g of x is, and then fill in what that is for your particular problem. And then say, okay, what is it that I'm going to need to do in order to get the answer to the question, what is the derivative? The answer is right here. Okay, but what is that? What is that I just put in a box? Well, there's four things there, aren't there, right? You can sort of hopefully see, right? There's four pieces to my answer. I need to know f of x, and I need to know g of x. Well, those are easy, because those are just whatever you see here and here. In other words, what did you write down here, and what did you write down there? So those are gimmies, right? Those are just going to be the things you see in the problem. Okay, but what are the other two things I need in order to get my answer? Is I'm going to need to know this, and I'm going to need to know this. In other words, I need to know the derivatives of both f and g. So it's going to be handy, and the other two rules are going to kind of work like this too, so this is a good habit for us to get into. To say to yourself, okay, you can maybe first say what's f and what's g down here at the bottom, And then you're going to need the derivative of f, and you're going to need the derivative of g. So compute them. Okay, and this is, again, probably via the chart and or some rules. So when you write down f and g, which is just whatever's in the problem, that's f and that's g, whatever two things you've got, write them down. And then, when I proceed through these problems, I immediately compute the derivatives of each guy. So whatever I write down for f here, I compute its derivative, and that's what I get here. And then whatever g is, I'd say, okay, and the derivative is blah, blah, blah. Now, once you've done that, this is now just an assembly problem, and the robot could do it now. Because now all I have to do is to say, okay, so my answer to the whole question, the answer to what is this derivative, is now made up of these four pieces. But you have all four pieces listed, right? You're going to have all four of these characters down here filled in. And so just put them together with their right buddies, right? So I'm going to put f of x with g prime. That's the first piece. And then I'm going to put f prime with g. That's the second piece. And that's the answer. And then I add, right? I'm sorry. And I add in between them. All right? So this looks god-awful, so do a little bit of a cleanup here. Clean that up. Clean that up. So let's see what we can say maybe about the example that I have up top there. All right, so when I look at this now, the product rule, which is what this is called, because it deals with the product, right, the multiplication of two functions, is the easiest one to get set up. I don't want to make anybody feel bad if they get it wrong, but you really can't mess this up too badly, I don't think, because when you look at any problem that needs the product rule, you're going to hopefully immediately say, well, there's one function, and there's the other function, right? In other words, this is f, x squared is f, and g is sine of x. It's kind of not, there isn't a whole lot that can go wrong, I don't think. So if I'm going to try to do my little routine down here, which is to say, let's fill these pieces in, that's the first thing I'm going to do is I'm going to say, well, I guess I should say first thing I would do if I have this problem is I would say, well, what is this thing? X squared times sine of x. Oh, look, I just said it. Times. Well, that means I need the product rule because it's multiplication. If that was x squared plus sine, I would use the addition rule. If that was x squared divided by sine, I would use the division rule, which we don't know yet, but that's the next one that's coming. So first things first, I guess I identify the rule I need, product rule. Okay. Then I say to myself, all right, product rule, that's this character. That's this whole thing at the bottom. So I say, all right, what is it that I should do to do the product rule? Well, if I'm trying to learn this and get good at it, I might first say, let me write down my two characters, f and g. And again, who are they? The first guy is f and the second guy is g. So in my problem here, hopefully it's clear, x squared is f, and g of x is sine of x. Right? I don't know how else to say that, so hopefully that's clear. All right, and so I've got my rule perfectly set up now, right? I've got f times g, yes, f times g, that's what I've got. And so now the derivative would be spelled out right here. But in order for me to know that, I need four things. Well, I've got two of the four, but not all four of them just yet. So let me come down here and let me do this and this. Okay? So let me also write down while I'm here. Let me write down the derivative of each of these two guys. And they're both in my chart. The derivative of x squared is 2x, and the derivative of sine of x is cosine. Okay, so once you've done these four pieces, you now have exactly what you need in order to finally write down the answer, which is right there. Just make sure you put everybody with the right partner, and you're all set. So what should my answer then be? Well, it would be f of x, right? So f of x, well, that's x squared. I'm going to just come over here and write my answer down. Okay, x squared, and then g prime is cosine. So I did x already, x squared. G prime is cosine of x, plus g, which is sine, times f prime, which is 2x. And that's the answer. Okay, you could rewrite this if you want. I can't really say a whole lot about that. This, I don't know, maybe it's just OCD, but it kind of always looks better to put this in front maybe. I don't know. You don't have to. It's totally fine to leave it like it was above. But that's sort of the nicest, I guess, way of expressing the answer. X squared times cosine of x plus 2x times sine of x. Now, how much harder was that than just a basic problem or a basic just, tell me what this is from the chart? Not much, right? I mean, I did need to use this product rule, as it's called, down here. But, we're not talking like an amazing amount of extra work, per se. It's just sort of, okay, fine. I have to do basically two versions, right? Or in other words, I have to kind of use the chart twice instead of once. And I have to do a little bit of assembly, right? Again, how many checks can I put around this box? I have to sort of put this thing together. But aside from that, there's not a whole lot to it. And like I said before, there isn't a whole lot of magic or mystery in getting it set up either, right? I mean, F and G are going to be hopefully pretty obvious what they are. So let me just do one more example. I got to go on to the next slide here. I don't have space, but let me just do one more for you before we move on. Let me just make up another example here. So maybe I've got something like maybe e to the x times times 3x squared minus 7x or something like that. Okay, so I again want to sort of look at a problem and say to myself, what am I looking at, right? What kind of a thing am I looking at? Well, I guess there would be more than one way to do this problem. You could distribute the e to the x, I suppose, but maybe let's not do that and just say, well, if I'm looking at this, I first and foremost recognize, hopefully, that it's a product of two things. It's e to the x, that's one guy, times that stuff in parentheses. That's the second guy. So it sounds like a product, right? And I have a rule for how to deal with a product. So I'm going to proceed using the product rule. So I say, all right, I'm going to get the product rule set up. And it's helpful, especially as you're learning this, to maybe identify what rule you're using and say, okay, right now I'm using the product rule, and I'm going to get it set up. So I'm going to, again, do the same little setup thing I did before, where I say, who are the two functions? And in this case, I've got e to the x times 3x squared minus 7x. So those are my two functions. And again, you could always just do a check. It's not that exciting or important to probably do it right now or for one this easy. But you should always just double check. Did I set it up right? Is the thing I'm trying to take the derivative of, is it really what I've written down for f times what I've written down for g? And it takes about 0.7 seconds to realize, yes, it is. I guess if you had written down something like this, I'm trying to think of how you might do this wrong, I guess. I don't know. I guess if you had just written that down, you might say, well, is what I'm trying to take the derivative of, is it e to the x times 3x squared? Well, that's part of it, but that's not the whole thing. And you always want to have, when you write down your first rule or your rule that you're going to use here, you always want to make sure you have the whole thing represented. So this is, this would be wrong because I lost the 7x, So just a good, a safe way of maybe just confirming, especially as you're getting better and better at this, is to just sort of double check. Do I have everything written down? And is it true that the thing I'm trying to take the derivative of, I'm alleging that this is the product rule. So is it true that the thing I want is f times g as I've chosen them? And the answer here, of course, is yes. Okay, being overly cautious here, so let's just continue. Now I know for the product rule I'm going to need the derivatives of each of these two guys. So again, I consult my chart, and the derivative of e to the x in my chart is e to the x. That's my favorite. And then the derivative over here on the right of 3x squared minus 7x, I'm not going to do this super slow, but this is technically what, a difference of two things. It's something minus something. But remember, we have a rule that says you can just do the difference of each derivative. So I'm going to do the derivative of 3x squared, and the derivative of 7x, and then I'm going to subtract. Okay, so each of these is also now technically an instance of the coefficient rule, where I'd say, so I have a 3 in front of x squared, so that's really 3 times the derivative of x squared. Okay, so the derivative of x squared is 2x. So here I would really get 6x. Okay, again, 3 from the 3 that's there, that's a coefficient that comes along. And then the derivative of x squared is 2x. So 3 times 2x, 3 times 2 is 6, so 6x. Okay, and then for 7x, I'd say, okay, so 7 is the coefficient, so 7 comes along. And then the derivative of x, if you look in the chart, is 1. Well, I'm not even going to write that down, right? 7 times 1 is just 7. Okay, so 6x minus 7. All right, and then the product rule, if I put the pieces together, tells me the answer to this question. What's the derivative of this guy that I started with? Okay, let's see. What does the product rule say? It's on the previous slide, but I remember it anyway, right? So it should be the first guy. It should be f, got it, times the derivative of g plus, sorry, now I don't remember which order I listed it in. Okay, g, that's this guy, times the derivative of f, which is e to the x. Sorry, that x looks a little funny. And that's the answer. You could simplify this if you wanted to, but let's not. I just sort of circle that or box that in and say that that's it, and that is the answer. So it's pretty good, right? It's pretty good to be able to, really just sort of break down a problem that is kind of, I guess, complicated, and it really actually isn't when you break it down this way. That's what's good about these rules, is that it makes hard problems into a series of easy problems. Okay, so I think that's it for the product rule. So let me go back, as I'm going to try to be good about doing this, and let's add that to our master list here. So the product rule now, got that. So again, that says if you have one function times another function, the derivative is the first one times the derivative of the second one plus the second one times the derivative of the first. Okay, so so that's the product rule. So what's next is, of course, going to be to deal with a quotient, or a division, I guess I'd say, of two functions. And then we'll have a fifth rule that is sort of our last guy, which is the hardest one for sure. So, but the quotient rule is what's next, which will tell us how to do the derivative of a fraction, basically, or of one function divided by another. But I'll do that in a separate video just to break this up a little bit more for you all. So, okay.